Hello friends, today we will talk about solar orbiter. The sun is Earth's closest stellar neighbor. It provides energy that allows life to exist on our planet. But that energy comes at a cost. The sun has a variable environment that includes solar flares, coronal mass ejections of charged particles, and the solar wind. It is important for scientists to have a better understanding of how the sun behaves on a daily basis because radiation emanating from it can affect astronauts or satellites in space. Solar Orbiter is 1,800 kg spacecraft lifted off atop a United Launch Alliance Atlas V rocket, rising off a pad at Space Launch Complex 41 here at Cape Canaveral Air Force Station on Sunday. The veteran launcher flew in a unique configuration featuring a 13-foot wide fairing and a single solid rocket booster. Solar Orbiter is a collaboration between European Space Agency and NASA. The mission is expected to return unprecedented data and images as well as our first views of the sun's polar regions, and the team of people behind it are thrilled. Solar Orbiter was designed to study the sun up close. Its main goal is to answer the question, how does the sun create and control the heliosphere, the huge protective bubble that surrounds our solar system? And why does that bubble change over time? Scientists believe the key to answering that question lies in the sun's polar regions. Solar Orbiter will be the first spacecraft to image this enigmatic region. The polar area holds the keys to unraveling the mysteries of the sun's activity cycle. The sun's magnetic field causes all the effects we see. Solar Orbiter will connect what's going on at the sun with what's happening out in the heliosphere in unprecedented detail. The probe's measurement will help establish a cause and effect relationship to what happens on the sun and what we observe in the near-Earth environment. Scientists first proposed this mission over 2 decades ago, in 1999. ESA officials originally planned for the mission to launch sometime between 2008 and 2013. However, technical difficulties and some mission reshuffling ultimately delayed the launch to 2020. ESA is leading the Solar Orbiter mission, with NASA paying for the launch vehicle and one of the 10 instruments on board. NASA's total monetary contribution to the mission is roughly $386 million, with ESA contributing $877 million out of a grand total cost of around $1.5 billion.
The solar orbiter is indeed going to be a major challenge for the mankind. This is largely because of the type of design changes that it goes on to require. There are many challenges in the design of the solar orbiter. The first is the thermal protection system. The thermal protection system for this spacecraft has been one of those challenges here. Now, over the years, the technology developments have enabled the scientists to better their spacecraft and its suite of ultra-sensitive instruments. To stay cool, the craft has 150 kg of a heat shield which is built to withstand temperature up to 520 degrees Celsius. It has a very intricate heat shield that is keeping it safe from the sun. And with these little peepholes that open when we want to look at the sun, but then close because the instruments are so sensitive. That means they keep on closing, keep on opening up, and they give a minutest amount of a peep towards the sun. The heat shield resembles a sandwich made up of many layers of titanium foil. And that foil, along with the parts of a spacecraft, is coated with a special material called as solar black that was created for the solar orbiter specifically. Made of calcium phosphate, that is, the same material as human bone, the coating has been used to help prosthetics bond with a human bone, reducing the chances of rejection. The bone-based coating, which covers a large portion of the spacecraft, has stable thermal properties and it is electrically conductive and will not slough off over the course of the mission. That means it will not go to slip out of it. White is a typical color choice for a spacecraft coating because it reflects the sun's rays. Unfortunately, it has certain major disadvantages. For example, the white coloring will darken over time as it is exposed to ultraviolet radiation, and not only ultraviolet radiation but almost all the forms of radiation emanating from the sun. That is, the alpha rays, the beta rays, the gamma rays as well, which may go on to be having some degree of an effect on it. This significantly changes the thermal properties of the spacecraft and can adversely affect its instruments. The solar orbiter has been unofficially dubbed as a blackbird as a nod to a special thermal protection system it goes on to have. This was one of the challenges. The second challenge is to ensure that the onboard instruments do not interfere with the magnetic field measurement the spacecraft will go on to take. This is largely because the basic aim of this spacecraft is to measure and to know the magnetic field of the sun. The third of this challenge, and that is a major challenge, that is indeed a challenge that not too many people can go on to think of, is the cleanliness. Cleanliness is a challenge because the instruments are sensitive to molecular contamination, and that any type of residue, dust particles or stray hair could spell disaster for the science expected from these instruments. This is the reason that it is made squeaky clean, so clean one cannot even imagine the type of a cleanliness one can ever imagine. The spacecraft was cleaner than it was required to be for the instruments to perform as expected, and that is why it is the cleanest spacecraft ever launched by the mankind. The fourth is, the spacecraft is also sensitive to water vapor. In fact, the craft's sensitive telescopes are not going to turn on for a while, so that any residual water vapor that formed during the launch will evaporate. Now, these are the challenges that had made it by and large unique and very, very exceptional as well.
Functions of solar orbiter. A suite of 10 science instruments will study the sun. There are two types, in situ and remote sensing.
Solar orbiter won't fly as close to the sun, but it brings unique skills. It brings unique information as well. First, the solar orbiter carries two types of instruments. One set, like Parker's, will study the spacecraft surrounding. The other, a set of telescopic instruments, will observe the visible surface of the sun itself at a distance. And partway through its mission, solar orbiter will leave the belt around the sun's middle, called the ecliptic, and begin encircling the sun at a tilt, allowing the spacecraft to use those telescopic instruments to produce the first ever images of the sun's pole. The in situ instruments measure the conditions around the spacecraft itself. The remote sensing instruments measure what is happening at large distances away. Together, both sets of data are going to be used to piece together a more complete picture of what is happening in the sun's corona and the solar wind. And these are two of them that once we happen to know, we'll go on to know a lot of things about how is it that they can go on to affect the whole of the Earth.
Gravity assist maneuvers at Earth and Venus will enable the solar orbiter spacecraft to change inclination to observe the sun from different perspectives. During the initial cruise phase, which lasts until November 2021, solar orbiter will perform two gravity assist maneuvers around Venus and one around Earth to alter the spacecraft trajectory, guiding it towards the innermost regions of the solar system. At the same time, solar orbiter will acquire in situ data and characterize and calibrates its remote sensing instruments. The first close solar pass will take place in 2022 at around a third of Earth's distance from the sun. The first good look at the sun's poles won't come until 2025, when solar orbiter will reach a trajectory of 17 degrees above the ecliptic plane where the Earth and the rest of the planets orbit. The spacecraft will achieve this vantage point via gravity assist flybys of Venus, which will boost its inclination. Solar orbiter's steepest viewpoint, 33 degrees above the ecliptic, won't come until 2029, when the spacecraft will be well into an expected extended mission, which would start in December 2026. That angle will provide the best images of the sun's polar regions. Although throughout the mission, the spacecraft will beam back unprecedented data about these never before seen regions. Our sun will never look the same again, thanks to the 2 solar probes and 1 giant telescope. The Solar Orbiter spacecraft, a collaboration between the ESA and NASA, less than 2 weeks after the first public image from a massive new solar telescope, showed of the structure of our star in more detail than humans have ever seen. Combining the data from all observatories is vital for scientists to accomplish the goal that drives the mission, to understand the sun and its influence throughout the solar system. The impacts of the sun's antiques ripple across the solar system as a set of phenomena called space weather. It's a great time to be a heliophysicist. We are launching lots of new missions. Thank you.